The concept of parallel universes captivates both scientists and the general public alike, offering a fascinating glimpse into possibilities beyond our known reality. Parallel universes, often referred to as alternate or multiple universes, are hypothetical realms that exist alongside our own, each potentially containing different versions of events, histories, or even entirely distinct laws of physics. This idea stretches our understanding of reality and challenges the notion of a single, unique universe. Interest in parallel universes arises from advances in quantum mechanics, cosmology, and theoretical physics, where models such as the many-worlds interpretation and the multiverse theory propose that countless universes coexist simultaneously. Beyond science, the idea touches on deep philosophical questions about existence, identity, and the nature of reality itself. It encourages us to reconsider our place in the cosmos and explore whether other versions of ourselves or alternative outcomes might exist somewhere beyond our perception. This work aims to explore the scientific foundations, technological challenges, cultural impact, and philosophical implications of parallel universes. By examining current research, skepticism, and the broader societal influence of these ideas, the study seeks to shed light on whether traveling between these worlds is possible and to consider the intriguing hypothesis that travelers from parallel universes might already be among us. The idea of parallel universes, while often associated with contemporary physics and science fiction, has roots that extend deep into the history of human thought, spanning ancient philosophy, religious beliefs, and early scientific speculation. The concept of multiple worlds or realities has evolved over centuries, influenced by shifts in philosophy, metaphysics, and scientific discovery. To understand the origins and development of the idea of parallel universes, it is necessary to trace its journey from ancient civilizations through the intellectual transformations of the 19th and 20th centuries, culminating in the sophisticated scientific hypotheses of modern times. In ancient philosophy, early notions of multiple worlds can be found scattered across different cultures and traditions. Some of the earliest ideas emerge from ancient Indian and Greek philosophy. Hindu cosmology, for example, described a cyclical universe with countless worlds that arise and dissolve over vast spans of time. These worlds existed in layers or planes of reality, often inhabited by different beings and governed by diverse laws. Similarly, in ancient Greek philosophy, the pre-Socratic thinkers toyed with ideas that suggested the existence of multiple worlds. Anaximander, one of the earliest Greek philosophers, proposed the concept of the apeiron, an indefinite or boundless substance from which all things arise, implying an infinite and possibly plural cosmos. Later philosophers such as Democritus, who theorized the existence of atoms moving in the void, entertained the possibility of an infinite number of worlds formed by these atoms. This was a radical departure from the then dominant view of a singular, geocentric universe. During the classical period, the philosopher Epicurus and his followers advanced the idea that the universe consisted of many worlds, some similar to our own and others quite different. They argued that the void was infinite and that atoms could combine to form countless worlds, which might arise and perish independently. Although their ideas were speculative and not based on empirical evidence, they introduced a framework that challenged monolithic views of reality. This philosophical pluralism laid the groundwork for later conceptions of a multiverse. With the rise of Christianity and other monotheistic religions in the Western world, the dominant worldview shifted toward the belief in a singular, divinely created universe with a fixed order. The idea of multiple worlds was largely suppressed or regarded as heretical because it conflicted with theological doctrines about creation and the uniqueness of the human soul. However, some medieval scholars and mystics entertained notions of multiple realms, such as heaven, hell, and purgatory, which, while spiritual rather than physical, hinted at layered or parallel existences. The Renaissance and the scientific revolution brought significant changes to humanity's understanding of the cosmos. The heliocentric model proposed by Nicholas Copernicus in the 16th century displaced Earth from the center of the universe, challenging long-held beliefs and opening the door for new ideas about the scale and structure of reality. The discoveries of Galileo Galilei, Johannes Kepler, and Isaac Newton further expanded knowledge of the heavens, revealing a vast and dynamic universe governed by natural laws. Although these developments did not directly propose parallel universes, they set the stage for questioning the uniqueness and boundaries of the cosmos. In the 17th century, the philosopher and mathematician René Descartes introduced mechanistic explanations of the universe, conceiving it as a vast machine governed by physical laws. Descartes also speculated on the existence of other worlds or realms beyond human perception, although his focus remained largely metaphysical. Around the same period, the idea of a plurality of worlds began to reemerge more explicitly in the works of writers and thinkers who pondered the possibility of other inhabited planets or realms. The poet and philosopher Giordano Bruno, for example, argued for an infinite universe with countless worlds similar to Earth, many inhabited by intelligent beings. Bruno's views were controversial and contributed to his persecution, yet they influenced later scientific and philosophical debates. The 18th and 19th centuries saw the idea of multiple worlds continue to develop alongside advances in astronomy, physics, and philosophy. The Enlightenment's emphasis on reason and empirical evidence encouraged scientists to consider the nature of the cosmos beyond Earth's immediate surroundings. Astronomers discovered new planets and stars, expanding the known universe and raising questions about life elsewhere. Philosophers such as Immanuel Kant and later Friedrich Nietzsche speculated about the nature of reality and the possibility of multiple worlds or dimensions. In the late 19th century, the emergence of modern physics began to profoundly alter conceptions of space, time, and matter. The discovery of electromagnetism, thermodynamics, and the theory of evolution challenged classical views and introduced new complexities into the understanding of the natural world. The concept of an infinite or multi-layered universe gained scientific credibility, and fiction writers of the period, inspired by these ideas, began exploring alternate realities and dimensions in literature. The 20th century marked a turning point in the formal development of parallel universe hypotheses. The advent of quantum mechanics in the early decades introduced fundamental uncertainties into physics, revealing that particles exist in probabilistic states rather than deterministic trajectories. This radical shift opened the door to interpretations that invoked multiple realities to explain observed phenomena. Hugh Everett's many-worlds interpretation, proposed in 1957, suggested that every quantum event branches into a separate universe, creating a vast multiverse where all possible outcomes occur. Though initially controversial, Everett's idea gained attention for resolving paradoxes related to quantum measurement. Simultaneously, developments in cosmology, particularly the theory of cosmic inflation proposed by Alan Guth in the 1980s, suggested that the rapid expansion of the early universe could produce bubble universes, separate regions of space-time with different physical constants. This notion of a multiverse has since been integrated into string theory and other theoretical frameworks, each describing a vast landscape of possible universes with varying properties. Throughout the 20th century, the interplay between philosophy and science continued to shape discussions of parallel universes. Philosophers examined the metaphysical implications of multiple realities, questioning the nature of identity, causality, and existence. Meanwhile, popular culture embraced parallel universes as fertile ground for storytelling in science fiction, film, and literature, making the idea accessible and captivating to the wider public. In conclusion, The idea of parallel universes has a rich and varied history that reflects humanity's evolving understanding of reality. From ancient philosophical musings about infinite worlds to sophisticated scientific models proposing countless universes, this concept has challenged and expanded our worldview. It embodies the enduring human desire to explore beyond the known, to imagine alternative possibilities, and to confront the mysteries of existence. The journey of this idea continues today as science and philosophy probe deeper into the nature of reality, seeking answers to questions that have intrigued thinkers for millennia. The concept of parallel universes has moved from the realm of philosophical speculation into serious scientific discourse, primarily through several key physical theories developed over the past century. These theories arise from efforts to understand the fundamental nature of reality at both the smallest scales, quantum mechanics, and the largest scales, cosmology. Among the most influential frameworks suggesting the existence of multiple universes are the many-worlds interpretation of quantum mechanics, string theory with its multidimensional branes, and the cosmological models associated with eternal inflation. Each of these theories provides a different perspective on how parallel universes might exist and interact, expanding the boundaries of what we consider possible within the physical universe. The many-worlds interpretation of quantum mechanics emerged in the 1950s as a response to the peculiar and counterintuitive behavior of particles at the quantum level. Traditional quantum mechanics, as formulated in the early 20th century, describes particles such as electrons and photons not as having definite positions or velocities until measured, but as existing in a superposition of multiple possible states simultaneously. When an observation occurs, the wave function, a mathematical description of all possible states, appears to collapse into a single outcome. This collapse, however, is difficult to reconcile with the deterministic equations governing quantum evolution and has led to numerous paradoxes, such as Schrödinger's famous cat thought experiment, where a cat is simultaneously alive and dead until observed. Hugh Everett III proposed the many-worlds interpretation as a way to resolve these paradoxes by eliminating the collapse postulate altogether. According to this view, every possible outcome of a quantum event actually occurs, but in separate, branching universes. For example, when a quantum measurement is made, the universe splits into different branches, each realizing one outcome. Thus, instead of a single history unfolding, there exists a vast, perhaps infinite, tree of parallel universes that encompass every possible variation of events. The implications are profound. Not only is reality far richer than it appears, but every decision, every random quantum event, spawns new universes where alternative outcomes play out. The many-worlds interpretation remains controversial because it suggests an unimaginably vast number of unobservable universes and raises questions about probability, identity, and the nature of existence itself. Nonetheless, it has gained traction among physicists because it provides a mathematically consistent and elegant solution to quantum mysteries without additional assumptions. Parallel to developments in quantum theory, string theory emerged as a candidate for a unified theory of everything, aiming to reconcile quantum mechanics and general relativity. String theory posits that the fundamental constituents of reality are not point-like particles, but tiny, vibrating strings whose modes of vibration correspond to different particles. One of the striking features of string theory is that it requires additional spatial dimensions beyond the familiar 3, often positing a total of 10 or 11 dimensions. These extra dimensions are typically compactified or curled up at scales too small to detect directly, but their presence profoundly affects the properties of particles and forces. Within string theory, the concept of branes, short for membranes, plays a crucial role in explaining how multiple universes might exist. Branes are multidimensional objects that can have various dimensionalities, such as a two-dimensional surface, a membrane, or higher dimensional analogs. Our observable universe could itself be a three-dimensional brane embedded within a higher dimensional space known as the bulk. Other branes could exist parallel to ours, each representing a separate universe with potentially different physical laws or constants. These parallel branes might be close or distant in the higher dimensional space, and their interactions could, in principle, produce observable effects such as gravitational anomalies or particle signatures. This brane world scenario provides a geometric and physical framework for the existence of multiple universes embedded within a richer higher dimensional reality. The brane concept in string theory opens possibilities for universe creation and interaction that go beyond traditional cosmology. For example, collisions between branes could trigger events resembling the Big Bang, giving rise to new universes. This idea integrates cosmology with string theory's higher dimensional physics, suggesting that our universe is only one sheet among many in a vast multidimensional structure. While string theory remains mathematically complex and experimentally unverified, its rich structure has inspired extensive research into the nature of parallel universes and the fundamental fabric of reality. In the realm of cosmology, the theory of inflation provides another compelling framework for the existence of a multiverse. Inflation posits that in the earliest moments after the Big Bang, the universe underwent a period of rapid exponential expansion driven by a high-energy vacuum state. This inflationary phase smoothed out irregularities and explains many observed features of the cosmos, such as its homogeneity and flatness. However, certain models of inflation suggest that this process may not have ended uniformly everywhere, leading to a scenario known as eternal inflation. Eternal inflation envisions a fractal-like cosmos in which bubble universes continuously form within an inflating background. Our observable universe is just one such bubble, where inflation has ended and normal expansion proceeds. However, beyond our bubble, inflation continues in other regions, producing an infinite or near-infinite collection of universes, each potentially with different physical properties or laws. This scenario creates a multiverse consisting of causally disconnected domains, each with its own history, constants, and structures. The concept is attractive because it naturally arises from the mathematics of inflationary cosmology and provides a potential explanation for the apparent fine-tuning of constants in our universe. If there are countless universes with varied parameters, it is not surprising that at least one, like ours, is hospitable to life. The inflationary multiverse theory also interacts with the anthropic principle, which suggests that the observed values of physical constants are conditioned by the requirement that observers exist to measure them. In a multiverse of diverse universes, we find ourselves in one where the conditions happen to support complex life. While this reasoning remains controversial and has philosophical implications, it provides a possible framework to understand why our universe appears so finely tuned. Each of these theories, the many worlds interpretation, string theory with branes, and inflationary cosmology, offers a distinct but sometimes overlapping perspective on the multiverse. They differ in the nature, origin, and relationship between universes, as well as in the mechanisms by which these universes might exist or interact. The many worlds interpretation stems from the quantum domain, focusing on branching realities produced by wave function evolution. String theory situates parallel universes within a higher dimensional landscape shaped by fundamental physical laws. Inflationary cosmology generates a vast ensemble of universes through dynamic processes in the early cosmos. Despite their differences, these theories share the remarkable implication that our universe may be just one of many, embedded within a much grander and more complex reality. However, it is important to note that all these ideas remain theoretical, constrained by current technological and observational limits. Direct evidence for parallel universes remains elusive, and many challenges exist in devising experiments that could confirm or falsify these hypotheses. Nonetheless, these physical theories have transformed the multiverse from a philosophical curiosity into a legitimate field of scientific inquiry, pushing the boundaries of physics and inspiring new ways to think about existence, reality, and the cosmos. In conclusion, the many-worlds interpretation of quantum mechanics, string theory with its brane-world scenarios, and the cosmological models of eternal inflation each contribute vital perspectives to the scientific discussion of parallel universes. They extend our understanding beyond the observable universe and challenge us to reconsider fundamental assumptions about space, time, and reality itself. While much remains uncertain and speculative, these theories continue to drive research and debate, opening doors to potentially revolutionary discoveries about the nature of the multiverse. The concepts of time and space travel have long fascinated humanity, fueling imaginations in science fiction and inspiring scientific inquiry alike. Both ideas challenge our intuitive understanding of reality and stretch the limits of what might be possible within the laws of physics. While time travel involves moving backward or forward along the temporal dimension, space travel concerns movement through the three-dimensional expanse of the universe. The hypotheses about transitioning between parallel universes often intersect with these notions, as they imply moving not only through space and time as we know them, but also potentially through alternative dimensions or realities. Understanding how ideas about time travel relate to and differ from hypotheses concerning parallel universe transitions is key to clarifying the scientific and conceptual frameworks behind these intriguing possibilities. At the core of both time travel and travel between parallel universes lies the structure of space-time itself, as described by the theory of relativity. Albert Einstein's theories fundamentally altered our understanding of space and time, showing they are not absolute, but interwoven into a four-dimensional fabric. This fabric can be warped and curved by mass and energy, leading to effects such as time dilation, where time passes differently depending on relative speed or gravitational strength. These insights open the door to theoretical models in which moving through time or space is not simply a matter of straightforward motion, but involves navigating the complex geometry of space-time. Time travel, in the sense of moving to the past or future, is often conceptualized through scenarios involving wormholes, closed time-like curves, or other exotic space-time geometries permitted by Einstein's equations under certain conditions. Wormholes, hypothetical shortcuts connecting distant points in space-time, could in theory allow for instantaneous travel between far-flung regions of space or even between different times. Such structures require exotic matter with negative energy density to remain stable, something that has not yet been observed. The possibility of traveling backward in time raises notorious paradoxes, such as the grandfather paradox, where a traveler's actions in the past might prevent their own existence. These challenges have sparked much debate about the consistency of time travel with fundamental physical laws. In contrast, the idea of traveling between parallel universes involves moving not only through space-time, but also across, or between separate, coexisting realities. These realities might differ in subtle or profound ways. Different physical constants, alternative histories, or divergent outcomes of quantum events. While time travel generally assumes a single, continuous timeline that can be revisited or altered, parallel universe travel presupposes multiple, possibly independent timelines or dimensions. The many-worlds interpretation of quantum mechanics, for example, implies a constantly branching tree of realities, each with its own version of events unfolding without interacting with the others. Transitioning between these branches would thus require mechanisms fundamentally different from those involved in traveling along a single timeline. Some speculative theories propose that wormholes or other exotic space-time constructs might serve as gateways not only through space and time, but also between universes. In such scenarios, the boundaries separating parallel worlds might be akin to membranes in higher dimensional space, and passage between them could be realized by traversing higher dimensional corridors. This blurs the line between time travel and inter-universe travel, suggesting that the two phenomena might be interconnected or manifestations of a deeper underlying structure of reality. Yet, these ideas remain highly theoretical, lacking empirical support or detailed models that can be tested experimentally. An important distinction between time travel and parallel universe travel lies in their implications for causality and the nature of reality. Time travel often entails the possibility of changing past events, which can create logical inconsistencies or paradoxes. Various proposed resolutions attempt to address these issues, such as the Novikov self-consistency principle, which asserts that events in time travel cannot contradict themselves, or the idea of multiple timelines branching off to accommodate changes. In contrast, parallel universe travel inherently involves moving to a different timeline or reality where actions do not retroactively affect the traveler's original universe. This can circumvent traditional paradoxes since each universe is self-contained and independent, but it also raises questions about identity, continuity, and the significance of causality across different realities. Philosophically, the idea of time travel engages with questions about determinism, free will, and the flow of time. If time is fixed and unchangeable, traveling to the past may be impossible or meaningless. If it is malleable, paradoxes emerge. Parallel universe hypotheses, by contrast, suggest a plurality of realities in which all possible outcomes occur, challenging the notion of a singular, linear history. This plurality can provide a different perspective on free will, as every choice might be realized in some branch of the multiverse. From a technological and physical perspective, both time travel and parallel universe travel face enormous challenges. The energy scales required to create or stabilize wormholes or other exotic space-time structures are far beyond current capabilities. Likewise, any mechanism for crossing between parallel universes would require a profound understanding of higher dimensional physics and the ability to manipulate space-time in ways not yet achievable. Current scientific instruments and experiments have not provided direct evidence for either phenomenon, although research into quantum entanglement, high-energy physics, and cosmology continues to explore the fundamental nature of reality and may one day illuminate these mysteries. In popular culture, time travel and parallel universe travel are often intertwined or conflated, with stories featuring characters jumping through time and alternate realities interchangeably. While this creative blending enriches narratives and explores profound human questions about identity, fate, and consequence, it sometimes obscures the distinct theoretical and conceptual issues involved. Understanding the differences between traveling in time within one universe and traveling between multiple universes helps clarify both the scientific debates and the imaginative possibilities. In conclusion, ideas about time travel and transitions between parallel universes share common roots in the complex structure of space-time and the fundamental laws of physics, yet they represent different kinds of movement and have distinct implications. Time travel involves navigating a single temporal dimension and faces challenges related to causality and paradoxes, while parallel universe travel involves crossing between separate realities with their own timelines and physical laws. Both remain speculative and face significant theoretical and practical obstacles, but they continue to inspire scientific investigation and philosophical reflection. Exploring their relationship deepens our understanding of reality's potential complexity and pushes the boundaries of what science and imagination can conceive. The idea of crossing between parallel worlds has captivated scientists and thinkers for decades, provoking a mixture of fascination and skepticism. While the notion of traveling to alternate realities has its roots in philosophy and fiction, modern theoretical physics has begun to explore mechanisms that, at least in principle, might allow for such extraordinary transitions. These speculative methods, ranging from wormholes to quantum tunneling and energy portals, are grounded in attempts to extend our understanding of space-time, quantum phenomena, and the fabric of the cosmos. Although no experimental evidence currently supports the feasibility of crossing between parallel universes, detailed theoretical analysis provides valuable insights into what such transitions would require and how they might manifest. One of the most widely discussed theoretical constructs for crossing between parallel worlds is the wormhole. Wormholes, also known as Einstein-Rosen bridges, are hypothetical tunnels or shortcuts through space-time that connect two distant points in space or potentially even two different universes. The concept arises naturally from solutions to Einstein's field equations in general relativity, which describe how mass and energy curve space-time. In a wormhole scenario, space-time is bent so drastically that two separate regions are linked by a tunnel-like structure, potentially allowing instantaneous travel between them. If one endpoint of a wormhole resides in our universe and the other in a parallel universe, it could serve as a gateway for crossing between worlds. However, wormholes pose significant theoretical and practical challenges. Maintaining a stable wormhole requires exotic matter with negative energy density to counteract the immense gravitational forces that would otherwise cause the tunnel to collapse. While quantum field theory predicts phenomena such as the Casimir effect that involve negative energy densities on small scales, it remains unclear whether sufficient exotic matter can exist in macroscopic quantities to stabilize a wormhole large enough for travel. Furthermore, even if such a wormhole could be created or discovered, navigating it safely would require overcoming unknown physical conditions, including intense tidal forces and potential causality violations. Despite these obstacles, wormholes remain a leading candidate for theoretical mechanisms enabling interuniversal travel, partly because they arise from well-established equations and offer a concrete geometric picture of connecting disparate regions of reality. Another intriguing mechanism considered in theoretical physics is quantum tunneling, a phenomenon already observed at microscopic scales. Quantum tunneling occurs when particles pass through energy barriers that classical physics deems impenetrable due to the probabilistic and wave-like nature of quantum mechanics. This effect enables particles to borrow energy briefly to traverse forbidden regions, an essential principle behind phenomena such as nuclear fusion and semiconductor operation. Extending the concept to macroscopic scales, some theorists speculate whether entire quantum states or systems could tunnel between different branches of the multiverse. In the context of the many worlds interpretation of quantum mechanics, quantum tunneling might provide a natural mechanism for transitions between parallel universes. Each universe represents a different outcome of quantum events, and tunneling could theoretically allow a system, or even a conscious observer, to shift from one branch to another. Such transitions would require conditions where quantum coherence is preserved across macroscopic scales, a scenario that remains highly speculative given the rapid decoherence effects typically observed in complex systems. Moreover, the probabilities for such large-scale tunneling events are expected to be extraordinarily low, making them effectively impossible within human timescales. Nevertheless, quantum tunneling remains a conceptually appealing possibility because it connects directly with fundamental quantum processes and the mathematical structure of wave functions. Energy portals or gateways constitute a broader category of hypothetical mechanisms for crossing between universes, often inspired by concepts from string theory, brane cosmology, and higher dimensional physics. In these models, Our universe is envisioned as a three-dimensional brane embedded within a higher dimensional space known as the bulk. Other branes, representing parallel universes, may exist nearby or be separated by extra dimensions inaccessible to ordinary matter and light. If the geometry of the bulk allows for intersections or near approaches of these branes, energy concentrations or exotic field configurations might create transient portals through which matter or information could pass. Such portals would require extraordinary energy densities or manipulations of the fundamental fields governing spacetime. Hypothetically, advanced civilizations or natural astrophysical phenomena might generate localized regions where the barriers between branes weaken or become permeable. In string theory and related frameworks, these portals could manifest as regions with unusual physical properties, such as altered gravitational or electromagnetic fields, that enable passage between worlds. Theoretical physicists have explored mathematical models describing how such energy portals might form, persist, or collapse, though these remain purely speculative without empirical support. Conditions for the existence of wormholes, quantum tunneling transitions, or energy portals depend heavily on the underlying physical laws and the nature of spacetime and quantum reality. For instance, the presence and properties of exotic matter are critical for stabilizing wormholes, while the coherence and isolation of quantum systems affect the likelihood of large-scale tunneling. Similarly, the geometry and dynamics of extra dimensions and branes influence the feasibility of energy portals. In many scenarios, the extreme energies, precise conditions, and technological sophistication required to create or access these mechanisms put them far beyond current human capabilities. Nonetheless, understanding these hypothetical methods helps frame the scientific and philosophical challenges posed by interuniversal travel. They illustrate how such transitions, if possible, would necessitate new physics or extensions of known theories. Moreover, studying these mechanisms deepens our grasp of the universe's fundamental structure and highlights the interplay between quantum mechanics, general relativity, and higher dimensional theories. In summary, the theoretical mechanisms for crossing between parallel worlds include wormholes, quantum tunneling, and energy portals, each rooted in different areas of physics and offering unique pathways for potential transitions. Wormholes provide a geometric bridge through spacetime, but require exotic matter for stability. Quantum tunneling leverages the probabilistic nature of quantum mechanics, but faces enormous challenges in scaling to macroscopic systems. Energy portals arise from higher dimensional physics and brane cosmology, suggesting ways universes might be connected through the fabric of extra dimensions. While all these concepts remain speculative, they form an essential part of ongoing efforts to explore the possibilities of multiverse travel and expand our understanding of reality's deepest layers. The exploration of practical challenges and limitations involved in traveling between parallel universes highlights the enormous gap between theoretical possibilities and feasible reality. While modern physics offers intriguing models suggesting that crossing into alternate worlds might be conceivable in principle, the technological and physical barriers standing in the way are profound. These challenges arise from the fundamental nature of the universe, the extreme energy demands of manipulating spacetime, the inherent instability of hypothetical transition mechanisms, and the complex quantum phenomena that govern information and matter at microscopic scales. A detailed analysis of these obstacles not only clarifies why such journeys remain speculative, but also illuminates the frontier areas where future scientific advances might one day reduce these barriers. One of the most significant practical obstacles is the astronomical amount of energy required to create or maintain the conditions necessary for interuniversal travel. Many theoretical models, such as wormholes or brane portals, involve manipulating space-time geometry or fields at levels far beyond what humanity currently can achieve. For instance, stabilizing a wormhole demands exotic matter with negative energy density, a substance that counteracts gravitational collapse. But producing or harnessing such matter in sufficient quantities remains purely hypothetical. Even if negative energy can be generated on microscopic scales, scaling it up to stabilize a macroscopic tunnel through space-time would require energy comparable to that of entire stars or black holes. Similarly, creating or accessing higher dimensional portals between branes might necessitate energy densities akin to those present at the earliest moments of the Big Bang, conditions far outside any present or foreseeable technology. Beyond raw energy requirements, the issue of stability presents another formidable challenge. The hypothetical structures that might enable transitions between universes are expected to be highly unstable and prone to rapid collapse. Wormholes, for example, without a continuous supply of exotic matter, would pinch off almost instantaneously, preventing any passage. Even minor perturbations, such as the passage of matter or radiation, could destabilize the delicate balance maintaining these tunnels. This instability makes controlled, repeatable travel effectively impossible under current theoretical frameworks. In addition, if transitions involve quantum tunneling of macroscopic systems, the extreme sensitivity of quantum coherence to environmental interference poses a severe limitation. Decoherence, the process by which quantum systems lose their coherence and behave classically due to interactions with their surroundings, acts extremely quickly on large objects. Maintaining quantum coherence over the duration and scale needed to tunnel between universes is far beyond current experimental capability. Quantum entanglement adds another layer of complexity. Entanglement, the quantum correlation between particles regardless of distance, suggests a deep interconnectedness of quantum states. Some theories speculate that entanglement might provide a pathway or communication channel between parallel universes. However, the no-communication theorem in quantum mechanics forbids using entanglement to transmit information faster than light or across separate realities in any straightforward way. This limitation constrains the possibility of using entangled particles to facilitate or stabilize transitions. Moreover, the fragility of entangled states in practical systems makes maintaining such connections over meaningful timescales extremely difficult. Any environmental noise or interaction with external systems tends to disrupt entanglement, making it challenging to exploit for crossing between universes. Another practical concern lies in the immense precision and control over space-time and quantum states required for these hypothetical transitions. Manipulating space-time geometry to create wormholes or portals necessitates technology capable of controlling gravitational fields and exotic matter distributions with unprecedented accuracy. Similarly, enabling quantum tunneling of macroscopic objects would demand isolation from all external disturbances and precise manipulation of quantum wave functions. Achieving such levels of control involves overcoming fundamental quantum limits, thermal noise, and technological constraints, all of which currently stand far beyond the reach of experimental physics. Furthermore, the very nature of the universes involved may impose unknown constraints. If parallel universes differ in their physical constants, laws, or dimensionality, traversing between them could involve encountering incompatible environments hostile to matter from our own universe. This raises questions about the survivability and integrity of travelers or probes crossing over. The lack of empirical data about the properties of other universes means these remain open theoretical questions, complicating any engineering or safety considerations. Theoretical limitations also include the problem of causality and temporal consistency. Some models of interuniversal travel suggest that moving between universes could entail temporal displacements or interactions with alternate timelines. Maintaining consistency and avoiding paradoxes or destructive interference between different realities is an unresolved conceptual challenge. Without a clear understanding of the fundamental rules governing interactions across universes, any practical implementation risks unforeseen consequences. In addition to purely physical and technological issues, there are formidable logistical and informational challenges. Constructing devices capable of generating or detecting signatures of parallel universes would require breakthroughs in instrumentation, sensors, and data analysis. The signals indicating a viable transition point, such as subtle gravitational anomalies or exotic particle signatures, may be faint, fleeting, or obscured by background noise. Extracting meaningful data from such environments demands innovations in experimental design and computational methods. Moreover, ethical and safety considerations arise when contemplating experiments or technologies capable of breaching the boundaries between universes. The risks of unintended consequences, such as contamination between worlds, destabilization of space-time regions, or exposure to unknown physical conditions, necessitate careful risk assessment and governance. These concerns add a layer of complexity to the practical pursuit of interuniversal travel, demanding multidisciplinary oversight involving physics, engineering, ethics, and policy. In summary, the practical challenges and limitations of traveling between parallel universes are daunting. The colossal energy demands, extreme instability of theoretical transition mechanisms, fragility of quantum coherence and entanglement, and the precision required for manipulating space-time all place such travel firmly beyond current technological reach. Additional uncertainties about the properties of other universes and the conceptual issues surrounding causality further complicate matters. While advances in physics and technology may gradually chip away at these barriers, the path to realizing travel between parallel worlds remains uncertain and fraught with profound difficulties. Understanding and confronting these challenges is essential not only for assessing the feasibility of such endeavors, but also for guiding future research into the deepest structures of reality. The quest to find empirical evidence for parallel worlds or alternate universes has propelled a variety of scientific investigations across multiple disciplines, including cosmology, quantum physics, and particle physics. While the notion of parallel universes remains largely theoretical, researchers have designed experiments and observations that might reveal subtle clues indicating the existence of realities beyond our own. These efforts focus on analyzing anomalies in cosmic radiation, probing the behavior of quantum systems, and scrutinizing high-energy particle collisions for signatures that could hint at interactions or connections with other universes. Although none of these studies have produced conclusive proof of parallel worlds, they have enriched our understanding of the universe and shaped ongoing inquiries into the multiverse hypothesis. One of the most promising avenues for detecting parallel universes lies in the detailed examination of the cosmic microwave background, CMB, radiation, the faint afterglow of the Big Bang that permeates all space. The CMB carries a wealth of information about the early universe, encoded in tiny temperature fluctuations and polarization patterns. These features reflect the distribution of matter and energy shortly after the universe's birth and have been meticulously mapped by satellites such as COBE, WMAP, and Planck. Some cosmologists have hypothesized that certain anomalies in the CMB might be interpreted as signs of collisions or interactions between our universe and other bubble universes in a multiverse framework. According to the inflationary multiverse model, our universe is just one of many bubbles formed in an eternally inflating cosmic landscape. If other bubbles exist nearby in the higher dimensional space, their interactions could leave subtle imprints on the CMB. Researchers have searched for circular patterns, cold spots, or unusual temperature discontinuities that deviate from expected statistical distributions. While some anomalies, such as the so-called cold spot, have drawn attention, the interpretations remain controversial and inconclusive. The statistical significance of these features is debated, and alternative astrophysical explanations are often more plausible. Nevertheless, the CMB remains a key observational target, as future missions with higher resolution and sensitivity might reveal clearer evidence of multiverse interactions or rule out certain models. Beyond cosmology, experiments in quantum physics explore the possibility that quantum phenomena might provide indirect evidence of parallel worlds. The many-worlds interpretation of quantum mechanics suggests that all possible outcomes of quantum events occur in branching, non-communicating universes. While this interpretation is difficult to test directly, some physicists have investigated whether quantum entanglement, coherence, or interference patterns could offer subtle clues about underlying multiverse structures. Quantum experiments involving superposition and entanglement have advanced remarkably in recent decades, with researchers achieving increasing control over larger and more complex systems. Studies of quantum decoherence, the process by which quantum systems lose their superposition due to environmental interaction, probe the boundary between classical and quantum realms. Some proposals suggest that deviations from standard decoherence models might hint at interactions with other branches of the multiverse, although such effects have not been observed. Additionally, experiments involving quantum computing and quantum simulation aim to test the limits of quantum mechanics, potentially shedding light on the validity of competing interpretations, including many worlds. High-energy particle physics, conducted at facilities such as the Large Hadron Collider, LHC, offers another window into the search for parallel universes. Particle collisions at extreme energies recreate conditions akin to those moments after the Big Bang, allowing scientists to probe the fundamental constituents of matter and the forces governing them. Some theoretical frameworks, including certain versions of string theory and extra-dimensional models, predict that signatures of other universes or dimensions might manifest as missing energy, unusual particle decay patterns, or production of microscopic black holes. Physicists analyze collision data for anomalies that cannot be explained by the standard model of particle physics. For example, the detection of gravitons leaking into extra dimensions or the production of exotic particles could provide indirect evidence for higher dimensional spaces harboring parallel universes. So far, no definitive signals have been found, but the experiments continue to refine our understanding of fundamental physics and constrain the parameters of multiverse theories. In addition to these mainstream scientific approaches, some researchers have explored more speculative observational strategies. These include searching for exotic astrophysical phenomena, such as unexplained bursts of radiation, gravitational waves with unusual signatures, or transient cosmic events that might be linked to interactions between universes. Advanced gravitational wave detectors like LIGO and Virgo have opened a new observational frontier, and while their discoveries so far align with predictions for black hole and neutron star mergers, future detections might uncover phenomena that challenge current cosmological models. Astronomical surveys and high-precision measurements of fundamental constants also play a role in testing multiverse theories. Some models predict that physical constants may vary slightly across different universes or even within different regions of our own universe. Detecting such variations would provide critical evidence supporting the existence of a multiverse. However, current observations indicate remarkable uniformity in constants like the fine structure constant and the speed of light, placing stringent limits on such variations. In the absence of direct evidence, much of the current scientific effort involves refining theoretical models and improving experimental sensitivity. Researchers continually develop new methods for analyzing data, searching for subtle statistical anomalies, and designing innovative experiments that push the boundaries of measurement precision. Collaborations between cosmologists, quantum physicists and particle physicists foster interdisciplinary approaches that enhance the chances of uncovering evidence for parallel worlds. While no experiment to date has definitively demonstrated the existence of parallel universes, the ongoing investigations are far from futile. They help clarify the limits of existing theories, guide the development of new physics, and deepen our understanding of the universe's origin and structure. Moreover, these scientific efforts inspire technological innovations in detectors, computation, and data analysis that have broader applications. In conclusion, the search for signs of parallel universes through cosmic microwave background anomalies, quantum experiments, and high-energy particle collisions represents a cutting-edge frontier in modern science. Despite the lack of conclusive results, these investigations provide valuable insights and maintain the possibility that empirical evidence for alternate realities could emerge. The interplay between theory and observation in this field exemplifies the dynamic nature of scientific inquiry, continually expanding our horizons and challenging our perceptions of reality. The concept of traveling between parallel worlds raises profound philosophical and ethical questions that challenge our understanding of personal identity, morality, and the consequences of interacting with realities beyond our own. These questions go far beyond the purely scientific or technological difficulties of such travel, delving into the nature of selfhood, the responsibility that might come with crossing into other universes, and the ethical implications of potentially altering or interfering with worlds inhabited by other beings, whether similar or fundamentally different from us. As the idea of parallel universes shifts from theoretical physics into the realm of possible experience, grappling with these philosophical and ethical issues becomes essential. At the heart of many philosophical considerations lies the question of personal identity. If one were to travel between parallel worlds, what would happen to the self? Would the traveler remain the same person, or would the experience of crossing realities fracture or multiply their identity? Some theories of the multiverse suggest that every decision or quantum event spawns alternate versions of individuals, each living divergent lives in different universes. If a traveler encounters or merges with such counterparts, the boundaries between distinct selves become blurred. This raises challenging questions about continuity of consciousness and whether identity is tied to a particular physical body, a unique stream of experience, or some underlying essence. If a traveler moves from one universe to another where a version of themselves already exists, does this create duplication or a form of coexistence? Would the traveler be morally responsible for the actions or fate of their counterparts? Conversely, if traveling involves inhabiting or replacing alternate versions of oneself, does that amount to erasure or usurpation of another person's existence? These considerations complicate notions of individuality and selfhood, pushing us to reconsider what it means to be a person in a multiverse context. Philosophers have long debated theories of identity, such as psychological continuity, bodily continuity, or narrative identity. But the existence of parallel selves across multiple worlds challenges all these frameworks, demanding new perspectives that account for multiplicity and overlap. Beyond personal identity, ethical dilemmas arise concerning interference with other realities. If travelers possess the capability to move between universes, they inevitably face choices about whether and how to interact with those worlds. Would it be permissible to intervene in the natural course of events in another universe? Should travelers attempt to help beings suffering from hardship or injustice in alternate realities, or would such interference violate principles of non-intervention and respect for the autonomy of other worlds? The classic ethical debate about intervention, well explored in contexts like colonialism, humanitarian aid, and environmental conservation, takes on new dimensions when applied to entire universes with their own histories and inhabitants. Interfering in other realities also raises concerns about unintended consequences. The butterfly effect, familiar in chaos theory, suggests that even small actions can cascade into massive changes over time. Introducing new technologies, ideas, or even individuals into a parallel universe might disrupt delicate ecological, social, or cosmic balances. The risk of causing harm, either through ignorance or arrogance, looms large. Travelers would bear responsibility for the ripple effects of their actions, yet predicting outcomes in complex, unfamiliar worlds could be impossible. This uncertainty demands caution and humility, echoing ethical principles emphasizing prudence and restraint when dealing with the unknown. Another ethical dimension concerns the rights and status of beings in parallel worlds. If these worlds host intelligent life, do those beings possess moral considerations similar to inhabitants of our own universe? Should travelers respect their autonomy, culture, and dignity? How would one navigate situations where values or norms differ radically between universes? The challenge of cross-cultural ethics magnifies when applied to beings potentially governed by different physical laws, social structures, or existential conditions. Ethical frameworks grounded in empathy, justice, and rights may require significant adaptation to accommodate such diversity. Moreover, the possibility of exploiting parallel worlds raises troubling ethical questions. If travelers discover resources, knowledge, or technologies in other universes, the temptation to extract or appropriate them for personal or societal gain could conflict with principles of fairness and respect. Parallels can be drawn to historical instances of exploitation and resource extraction on Earth, highlighting the potential for repeating patterns of harm on a multiversal scale. Ethical frameworks would need to address issues of consent, sovereignty, and environmental stewardship across worlds. The prospect of parallel universe travel also stimulates reflection on the meaning and value of existence. Encountering alternate versions of oneself or wholly different realities might challenge one's sense of purpose, uniqueness, and connection. It may provoke existential questions about destiny, free will, and the significance of choices if every possibility is actualized somewhere. These philosophical implications touch on deep human concerns about identity, meaning, and our place in the cosmos, extending them into new dimensions of complexity. Furthermore, the act of traveling between universes might itself pose ethical questions about consent and autonomy. Would potential inhabitants of other worlds have any say in whether outsiders enter their reality? Would the mere presence of travelers constitute a form of violation or intrusion? These concerns echo debates about privacy and boundaries, but expanded to a cosmic scale. Respecting the sovereignty of other universes could be a fundamental ethical imperative, necessitating protocols and principles for interuniversal conduct. Lastly, the ethical consequences of contact between universes extend to potential risks to the travelers themselves and their home universe. Exposure to unknown physical laws, diseases, or entities might pose dangers, raising questions about the responsibility of governments, institutions, or individuals to safeguard travelers and their societies. Moreover, the potential for cross-universal contamination, biological, informational, or otherwise, might threaten the integrity of both worlds, requiring ethical deliberations about containment and protection. In summary, the philosophical and ethical questions surrounding travel between parallel worlds are vast and multifaceted. They challenge traditional concepts of personal identity by confronting us with the possibility of multiple selves and overlapping existences. They compel careful consideration of the morality of intervening in other realities, emphasizing respect, caution, and responsibility. Ethical dilemmas about exploitation, consent, and sovereignty echo familiar human struggles, but on an unprecedented scale. Simultaneously, these questions invite profound reflection on the nature of existence, free will, and meaning in a universe, or multiverse, rich with possibilities. As science advances and the idea of parallel universe travel moves from speculation toward potential reality, grappling with these philosophical and ethical dimensions becomes not only necessary but urgent, guiding how humanity might responsibly navigate the vast unknown beyond our world. The concept of parallel universes has captured human imagination for centuries, manifesting in diverse cultural expressions across myths, religions, literature, and cinema. These representations not only reflect our deep curiosity about alternative realities, but also shape popular perceptions and philosophical reflections on the nature of existence, identity, and destiny. Throughout history, the idea of worlds existing alongside or beyond our own has appeared in various forms, often serving as metaphors for spiritual beliefs, moral lessons, or explorations of the human psyche. In modern times, scientific theories about the multiverse have reinvigorated artistic and cultural engagement with parallel universes, giving rise to a rich tapestry of stories that continue to influence how society understands the possibility of alternate realities. Mythologies from different cultures often incorporate the idea of multiple worlds or realms existing simultaneously or in succession. Many ancient belief systems describe a layered cosmos where gods, spirits, and humans inhabit distinct but interconnected planes. For example, Norse mythology presents the concept of Yggdrasil, the world tree connecting 9 realms, including Asgard, home of the gods, Midgard, the human world, and other mystical domains. These worlds coexist, influencing one another through various mythic narratives, suggesting an early intuition of parallel or overlapping realities. Similarly, in Hindu cosmology, the universe is seen as composed of multiple lokas or realms, inhabited by different beings and governed by distinct laws. These mythic models convey a worldview where the fabric of existence is complex and multifaceted, resonating with contemporary multiverse theories. Religious traditions often use parallel or alternate worlds metaphorically to address questions of morality, afterlife, and transcendence. Concepts of heaven, hell, purgatory, and spiritual planes represent different states or realms where souls might reside or journey. In many ways, these religious notions align with the idea of distinct realities coexisting, though typically imbued with spiritual and ethical significance rather than physical or scientific attributes. The idea of spiritual journeys to other worlds, such as shamanic travels to spirit realms or mystical experiences of divine dimensions, reflects a long-standing cultural fascination with crossing boundaries between realities. Such beliefs reinforce the human desire to understand existence beyond the material world and explore the unknown dimensions of consciousness. In literature, the theme of parallel universes has been explored extensively, evolving from allegorical or fantastical settings to more scientifically inspired narratives. Early works often used alternate worlds to question social norms, ethics, and human nature. For instance, in Lewis Carroll's Through the Looking Glass, 1871, Alice enters a mirror world that mirrors and distorts her familiar reality, inviting reflection on identity and logic. The idea of stepping through a portal into a different world became a recurring motif in fantasy literature, exemplified by C.S. Lewis's The Chronicles of Narnia, where children travel to a magical parallel realm with its own history and rules. The 20th century saw the rise of science fiction as a genre that seriously engaged with the scientific and philosophical implications of parallel universes. Writers such as H.G. Wells, Philip K. Dick, and Jorge Luis Borges explored themes of alternate realities, multiple timelines, and fragmented identities. Borges's short stories often blur the boundaries between fiction and reality, presenting labyrinthine worlds that coexist and intersect, challenging linear notions of time and space. Philip K. Dick's novels frequently depict characters navigating unstable realities or parallel worlds, reflecting anxieties about perception, reality, and the self. These literary explorations deepen the cultural conversation about what parallel universes might mean for human experience and knowledge. Cinema, as a powerful medium of visual storytelling, has played a crucial role in popularizing and shaping the public's imagination of parallel universes. Films like The Matrix Trilogy, 1999 to 2003, depict a simulated reality overlaying the true world, inviting questions about perception, control, and freedom. Inception, 2010, explores layers of dream worlds, effectively creating nested realities that challenge the distinction between real and imagined. The Marvel Cinematic Universe has extensively developed the concept of a multiverse, portraying characters who traverse alternate Earths and timelines, each with unique versions of familiar heroes. These cinematic portrayals combine spectacle with philosophical inquiry, making abstract scientific and metaphysical ideas accessible and engaging to mass audiences. Television series have also embraced the theme, with shows like Fringe, Stranger Things, and Rick and Morty integrating parallel universe narratives into their plots. These series explore the personal and societal consequences of crossing between worlds, often blending science fiction with emotional and ethical dilemmas. Rick and Morty, in particular, uses dark humor and absurdity to reflect on the infinite possibilities of multiverse theory and the implications for meaning and morality. By weaving parallel universe concepts into popular culture, these works influence how people think about identity, destiny, and the nature of reality itself. Parallel universes also appear in video games, comics, and graphic novels, expanding the cultural reach of this theme into interactive and visual formats. Games like BioShock Infinite and The Legend of Zelda, A Link Between Worlds, immerse players in worlds where alternate dimensions impact the narrative and gameplay, allowing audiences to experience the complexity of parallel realities firsthand. Comic book storylines, such as DC's Crisis on Infinite Earths and Marvel's Secret Wars, use multiverse events to bring together diverse characters and story arcs, creating rich, interconnected mythologies that reflect and reinforce multiverse ideas. The widespread cultural representation of parallel universes has shaped public perception by framing the concept as both a fascinating scientific possibility and a profound metaphor for human experience. These narratives often highlight themes of choice, consequence, and identity, emphasizing that our reality might be just one among many. They invite audiences to imagine how different decisions or conditions could lead to vastly different worlds, fostering a sense of wonder and humility about the cosmos. At the same time, cultural portrayals sometimes perpetuate misconceptions or oversimplifications of scientific theories. For instance, the idea that traveling to parallel universes is as easy as stepping through a portal, or that alternate worlds are simply copies of our own with minor differences, can obscure the complexity and nuance of the underlying physics. Nevertheless, the interplay between culture and science creates a feedback loop where popular media inspires scientific curiosity and scientific discoveries influence storytelling. In conclusion, the theme of parallel universes permeates myths, religions, literature, and cinema, reflecting humanity's enduring fascination with the idea of multiple realities. These cultural representations shape how societies envision the multiverse, blending imagination, philosophy, and science into narratives that resonate with fundamental questions about existence, identity, and destiny. As scientific exploration of parallel worlds progresses, cultural expressions will undoubtedly continue to evolve, enriching our collective understanding and inspiring new ways of thinking about the vast possibilities that lie beyond our own universe. The hypothesis that travelers from other universes might already be among us is a fascinating and provocative idea that bridges the boundaries between speculative physics, philosophy, and popular culture. This concept posits that not only do parallel universes exist, but that entities, whether human or otherwise, have found a way to cross the divide between realities and have come to inhabit our world. While this notion remains unproven and largely speculative, it has captivated the imagination of researchers, theorists, and the public alike, prompting a range of ideas, assumptions, and claims that warrant thoughtful consideration. At the core of this hypothesis is the idea that if parallel universes are real, and if there exist pathways or mechanisms enabling travel or transition between them, then it is plausible that some form of interuniversal migration or visitation has already occurred. This concept challenges our conventional understanding of reality and identity by suggesting that the boundaries between distinct universes may be more permeable than traditionally believed. It opens up the possibility that individuals or beings from parallel worlds, perhaps possessing knowledge, technologies, or physical characteristics unfamiliar to us, might be living unnoticed or misunderstood within our society. One motivation for entertaining this hypothesis comes from reports of anomalous phenomena and unexplained encounters that defy conventional explanation. Throughout history and across cultures, there have been accounts of mysterious figures appearing or disappearing without trace, strange beings exhibiting unusual abilities, and inexplicable events that suggest the presence of entities not entirely of this world. Some interpret these stories through the lens of interuniversal travel, proposing that such beings could be travelers or visitors from alternate realities. Whether these accounts are interpreted as folklore, supernatural events, or misidentified natural phenomena, their persistence fuels speculation about the possibility of parallel universe travelers. Modern popular culture has played a significant role in shaping and popularizing the idea that travelers from other universes might be among us. Science fiction literature, films, and television series frequently explore scenarios in which characters cross into our world from parallel dimensions, sometimes hidden in plain sight or interacting covertly with humans. These fictional depictions often inspire real-world curiosity and sometimes even claims of direct experience or contact with such travelers. While these narratives are primarily imaginative, they influence how people interpret unexplained events or phenomena, blurring the line between fiction and belief. Some proponents of the hypothesis argue that advanced civilizations in parallel universes might have developed technologies far beyond our current understanding, enabling them to navigate the multiverse and visit other realities, including ours. If such civilizations exist and have the capability for interuniversal travel, their representatives or emissaries could theoretically be present on Earth, either for exploration, observation, or interaction. This assumption aligns with broader ideas about extraterrestrial life and the search for intelligent beings beyond our planet, extending the scope to include parallel worlds rather than distant galaxies alone. Within this context, a variety of claims have emerged suggesting that certain individuals on Earth might be travelers from parallel universes. These claims often arise in fringe or paranormal communities and are typically based on anecdotal evidence, personal testimonies, or interpretations of unusual behaviors and abilities. Some individuals assert that they have memories or experiences indicating origins in other realities, or that they possess knowledge or skills inexplicable by conventional means. Others suggest that certain historical or contemporary figures exhibit signs of being interuniversal travelers, pointing to enigmatic biographies, sudden appearances, or remarkable achievements as circumstantial evidence. Skeptics argue that such claims lack rigorous scientific verification and are often the result of psychological phenomena, misinterpretations, or deliberate fabrication. Nonetheless, The persistence of these narratives highlights a human desire to explore the unknown and to find meaning in mysteries that evade conventional explanation. The idea that travelers from parallel universes might be among us resonates with fundamental questions about identity, belonging, and the limits of human knowledge. Philosophically, the hypothesis raises intriguing questions about the nature of existence and consciousness. If an individual is a traveler from a parallel universe, what does this mean for their identity within our world? Are they fundamentally different beings, or simply versions of humans displaced across realities? How would such an origin affect their sense of self and their relationships with others? These questions intersect with debates in metaphysics and philosophy of mind, complicating traditional notions of individuality and continuity. Moreover, the presence of travelers from other universes, if true, would have profound implications for society and culture. It would challenge our assumptions about the uniqueness of our reality and the exclusivity of human experience. It might prompt new frameworks for understanding diversity, knowledge, and cooperation across realities. On the other hand, it could also provoke fear, mistrust, or conflict, especially if such travelers are perceived as threats or outsiders. The social and political ramifications of acknowledging interuniversal visitors would be significant and far-reaching. From a scientific perspective, confirming the presence of travelers from parallel universes would revolutionize physics, cosmology, and our understanding of the multiverse. It would imply that the barriers between universes are surmountable and that interuniversal communication and interaction are possible. Such a discovery would open entirely new fields of study, focusing on the mechanisms of travel, the properties of alternate realities, and the nature of consciousness across universes. It would also necessitate rigorous methods for detecting and studying these travelers, integrating physics with other disciplines such as psychology, anthropology, and even sociology. While no definitive empirical evidence currently supports the hypothesis that travelers from parallel universes are among us, ongoing scientific investigations continue to explore phenomena that might relate to the multiverse. Advances in quantum physics, cosmology, and high-energy particle experiments strive to uncover signatures or anomalies that could hint at the existence of other realities. These efforts contribute indirectly to the plausibility of interuniversal travel and the potential for such travelers to exist. In summary, the hypothesis that travelers from other universes might already be present on Earth is a compelling idea rooted in the intersection of scientific possibility, cultural narratives, and philosophical inquiry. It challenges our understanding of reality, identity, and the boundaries between worlds, inviting us to consider the vastness and complexity of existence beyond our immediate perception. Whether viewed as a serious scientific question, a metaphysical speculation, or a cultural myth, the notion of interuniversal travelers continues to inspire curiosity and debate, reflecting humanity's enduring fascination with the unknown and the infinite possibilities of the multiverse. Throughout history, countless stories, legends, and eyewitness accounts have documented anomalous phenomena, events and encounters that defy conventional explanation. Many of these mysterious occurrences have been interpreted by some as possible evidence for the presence of travelers from parallel universes. While such interpretations remain speculative, these accounts provide a rich tapestry of narratives that fuel the hypothesis that beings or individuals from other realities might be interacting with our world in subtle or dramatic ways. These phenomena include mysterious disappearances, strange sightings, inexplicable behaviors, and encounters with entities that do not conform to known biological or physical categories. One of the most enduring types of anomalous phenomena involves mysterious disappearances of people, animals, or objects without any trace or logical explanation. Throughout folklore and modern reports alike, there are numerous cases where individuals vanish suddenly and inexplicably, leaving behind baffled witnesses and no concrete leads. Such disappearances sometimes occur in remote or peculiar locations, such as dense forests, remote wildernesses, or areas associated with legends of portals or otherworldly gateways. These events often spark speculation that the missing persons may have inadvertently crossed into a parallel universe or been transported there by unknown means. The lack of physical evidence fuels theories that traditional investigative methods cannot reach or comprehend the nature of such transitions, suggesting the involvement of realities beyond our own. In addition to disappearances, there are many accounts of strange sightings and encounters with entities that appear unfamiliar, sometimes described as non-human or exhibiting extraordinary features. These beings may possess unusual physical characteristics, such as altered proportions, glowing eyes, or shifting forms, which defy classification within known species. Eyewitnesses frequently report feelings of intense fear, confusion, or awe during these encounters, suggesting that the entities are perceived as distinctly otherworldly. In some cases, these beings are described as silent observers, appearing briefly before vanishing, while in others, they engage in more prolonged interactions. The ambiguity and otherness of these encounters lead some to interpret these entities as travelers from parallel worlds who have crossed into our reality, either intentionally or accidentally. Legends and folklore from various cultures often include stories of mysterious visitors or beings who appear suddenly, sometimes offering wisdom, warnings, or cryptic messages before disappearing again. These narratives, passed down through generations, share common motifs of crossing boundaries between worlds, altered states of reality, and the presence of enigmatic figures with knowledge beyond ordinary human experience. Such myths frequently describe otherworldly realms accessible through portals, caves, or natural features, echoing contemporary ideas about gateways to parallel universes. These traditional tales provide a cultural framework that makes it easier for modern witnesses to interpret anomalous experiences as interactions with parallel universe travelers, blending ancient beliefs with modern hypotheses. In recent decades, modern testimonies and reports of unusual phenomena have proliferated, often fueled by advances in communication technology and increased public interest in paranormal and unexplained events. These accounts include unexplained lights in the sky, strange humanoid figures captured on video, sudden unexplainable disruptions of electronic devices, and experiences of time distortion or reality shifts reported by individuals. While many such phenomena can be attributed to misidentifications, natural occurrences, or psychological factors, a subset remains resistant to conventional explanations. Some researchers and enthusiasts propose that these anomalous events might be manifestations of the interactions between our universe and parallel ones, possibly caused by brief or unstable crossings, bleed-through effects, or the presence of beings able to manipulate or exist across realities. The phenomenon of missing time, reported in some encounters, is another puzzling element often cited as evidence of parallel universe involvement. Individuals describe episodes during which they lose awareness of several minutes or hours, with no memory of what transpired. These experiences sometimes coincide with sightings of strange lights or entities, leading to hypotheses that the affected individuals were transported, observed, or even temporarily abducted by travelers from other worlds. Such accounts blur the lines between physical reality and altered perception, raising questions about the nature of consciousness and its relationship to parallel realities. Some stories involve objects that appear, disappear, or change properties in inexplicable ways. For example, items may vanish from one location and reappear elsewhere, or people report handling objects with unfamiliar materials or technologies not known on Earth. These anomalies suggest the possibility of cross-dimensional exchanges, where physical matter from parallel worlds somehow intersects with our own. The idea that travelers might bring artifacts or inadvertently leave behind traces adds another dimension to the search for evidence of parallel universe visitors. Encounters with entities that communicate telepathically or convey knowledge of future events have also been reported, lending a further layer of intrigue. These interactions often challenge conventional notions of communication and time, suggesting the presence of beings with advanced cognitive abilities or access to information beyond our temporal constraints. Some interpret these phenomena as signs that travelers from alternate realities possess unique ways of perceiving and interacting with the universe, which could include heightened mental faculties or access to higher dimensions. While many of these anomalous reports remain anecdotal and lack empirical verification, they collectively contribute to a body of evidence that some consider worthy of serious scientific and philosophical examination. Skeptics argue that human perception is fallible, prone to error, bias, and the influence of cultural narratives, and that many unexplained phenomena have plausible natural or psychological explanations. Nevertheless, the persistence and global distribution of such accounts suggest that the mysteries they represent are not confined to isolated incidents or cultures. Some researchers have sought to categorize and analyze these phenomena using rigorous methods, attempting to identify patterns or correlations that might support the hypothesis of parallel universe involvement. They study the geographic distribution of incidents, temporal clusters, and the types of entities or phenomena reported, looking for clues that could distinguish genuine inter-universal encounters from hoaxes, misinterpretations, or hallucinations. Though definitive conclusions remain elusive, these efforts reflect an increasing willingness within some scientific and investigative communities to explore the possibility that our reality may not be as singular or closed as traditionally believed. In popular culture, the interpretation of anomalous phenomena as evidence of parallel universe travelers has inspired numerous books, documentaries, and media productions. These works often blend eyewitness testimony with speculative theories, sometimes blurring the line between entertainment and serious inquiry. While this popularization can lead to sensationalism or the propagation of unverified claims, it also serves to raise public awareness and stimulate interest in the broader questions about the nature of reality and the potential existence of other worlds. In conclusion, stories, legends, and modern testimonies of anomalous phenomena offer a complex and compelling body of narratives that some interpret as evidence for the presence of travelers from parallel universes. Mysterious disappearances, encounters with non-human entities, unexplained physical effects, and reports of altered perceptions collectively challenge our understanding of reality and suggest the possibility that other realities may intersect with our own. While scientific confirmation remains lacking, the persistence of these phenomena encourages ongoing exploration and reflection on the boundaries of existence and the unknown dimensions that might lie beyond. The hypothesis that traveling to parallel universes is possible and that travelers from such realities might already be among us has captured the imagination of many, blending elements of cutting-edge physics with philosophical speculation and popular culture. However, despite its appeal, this idea faces substantial skepticism and critique from the scientific community. Several logical, empirical, and methodological objections challenge the feasibility of inter-universal travel and the presence of such travelers on Earth. These critiques highlight the difficulty of reconciling extraordinary claims with the rigorous standards of scientific inquiry and caution against accepting speculative hypotheses without robust evidence. One of the central arguments against the idea of traveling to parallel universes is rooted in the lack of empirical evidence. Science relies heavily on observable, measurable phenomena that can be independently verified and reproduced. To date, there has been no direct, unequivocal observation of a parallel universe or an entity crossing from another reality into our own. Despite decades of research in quantum mechanics, cosmology, and particle physics, no definitive experimental data has demonstrated the existence of interuniversal travel or the presence of travelers from other universes. This absence of concrete evidence remains a significant obstacle to accepting the hypothesis beyond theoretical speculation or anecdotal reports. From a logical perspective, the concept of traveling between parallel universes introduces profound challenges related to causality, consistency, and physical laws. If multiple universes exist with distinct physical parameters, structures, or timelines, then the mechanisms by which a traveler could move between them become exceedingly complex. Many interpretations of quantum mechanics and cosmology suggest that parallel universes, if they exist, are causally disconnected, meaning that events or entities in one universe cannot influence or interact with those in another. This causal isolation implies that crossing over might be impossible or that any interaction would violate fundamental principles of physics. Moreover, even if hypothetical pathways such as wormholes or quantum tunnels were theoretically possible, their stability and accessibility pose further problems. Wormholes, for instance, require exotic matter with negative energy density to remain open, a form of matter that has not been conclusively demonstrated to exist. The energy requirements to create or sustain such passages would likely be astronomical, far beyond any technology humanity can currently conceive. These physical and technological barriers suggest that even if interuniversal travel is not fundamentally forbidden by the laws of physics, it remains practically unattainable, at least with our present understanding. Methodologically, the hypothesis struggles to meet the criteria of falsifiability and testability, which are cornerstones of scientific methodology. For a theory or claim to be scientifically valid, it must be possible to conceive of experiments or observations that could potentially prove it false. The notion of travelers from parallel universes is often framed in ways that make it difficult to design rigorous tests or to rule out alternative explanations. Many purported encounters with such travelers rely on anecdotal evidence, personal testimonies, or ambiguous phenomena that can be interpreted in multiple ways. These forms of evidence are inherently subjective and vulnerable to bias, misperception, and fabrication, making it challenging to establish the hypothesis on a firm scientific footing. Additionally, many reports of anomalous phenomena or non-human entities cited as evidence for parallel travelers have alternative explanations grounded in psychology, sociology, or known physical phenomena. Human perception is prone to error, and experiences described as encounters with otherworldly beings may result from hallucinations, sleep paralysis, or psychological disorders. Cultural influences and expectations can also shape how individuals interpret ambiguous stimuli, leading to the creation of narratives that fit prevailing myths or popular theories. The prevalence of hoaxes and deliberate fabrications further complicates the task of discerning genuine phenomena from false claims. The hypothesis also faces challenges from the standpoint of theoretical physics. While certain interpretations of quantum mechanics, such as the many-worlds interpretation, allow for the existence of parallel universes, these universes are generally considered to be non-communicating branches of a wave function. According to this view, once universes diverge, they do not interact or exchange information. This understanding undermines the possibility of travel or interaction between these branches. Alternative cosmological models proposing multiverses often describe universes as separated by dimensions or realities inaccessible to each other. Thus, even within the scientific theories that suggest a multiverse, the concept of crossing between universes remains speculative and highly problematic. Critics also point out the absence of any physical traces or definitive markers of travelers from parallel universes in our reality. If such travelers existed and moved among us, it is reasonable to expect some form of detectable evidence, be it technological artifacts, anomalous biological signatures, or consistent, reproducible phenomena. The lack of such evidence weakens claims that these travelers are present on Earth. In science, extraordinary claims require extraordinary evidence, and without tangible proof, the hypothesis remains outside the realm of accepted knowledge. Furthermore, from a philosophical and epistemological perspective, the burden of proof lies with those making extraordinary assertions. The claim that parallel universe travelers are among us challenges the default assumption that our universe is self-contained and that no cross-universal interaction occurs. Without robust evidence, it is more parsimonious to explain anomalous phenomena within established frameworks rather than invoking interuniversal travel. This principle of parsimony, or Occam's razor, encourages scientists and thinkers to favor simpler explanations that require fewer assumptions, unless compelling evidence demands otherwise. In addition to scientific and logical objections, the hypothesis raises concerns about the potential for cognitive biases and social dynamics to distort perceptions and interpretations of unexplained phenomena. Humans have a tendency toward pattern recognition and meaning-making, which can lead to the identification of connections where none exist. This cognitive inclination can foster beliefs in extraordinary claims, especially when reinforced by community validation or cultural narratives. The spread of misinformation, sensationalism, and conspiracy theories related to parallel universe travelers further complicates objective assessment and fuels skepticism. Critiques also address the use of scientific terminology in ways that may mislead or confuse. Terms like quantum tunneling, wormholes, and multiverse are often appropriated in popular discourse without adequate understanding of their precise meanings or limitations. This misuse can create the illusion that scientific support exists for ideas that remain highly speculative or untested. Skeptics caution against conflating theoretical possibilities with practical realities and emphasize the importance of distinguishing between scientific hypotheses and science fiction. In sum, the hypothesis of traveling to parallel universes and the presence of travelers among us faces substantial scientific skepticism grounded in the absence of empirical evidence, logical contradictions, methodological challenges, and alternative explanations rooted in known phenomena. While the idea remains an intriguing and imaginative possibility, it has yet to meet the rigorous standards required for acceptance within the scientific community. Ongoing research in physics and cosmology continues to explore the nature of reality and the multiverse, but claims of interuniversal travel and visitation demand extraordinary evidence that has not yet been forthcoming. Until such evidence emerges, the hypothesis remains a speculative concept, captivating in imagination but unproven and contested in science. The idea of parallel universes has had a profound impact on both scientific thought and broader society, influencing not only the trajectory of theoretical physics, but also the way the public engages with science, the evolution of philosophical worldviews, and various cultural trends. This hypothesis, while still largely speculative, has captured imaginations worldwide and has become a powerful narrative that bridges complex scientific ideas with existential questions about reality, identity, and the nature of existence. Its influence can be observed in multiple dimensions, shaping research directions, educational approaches, artistic expression, and societal perspectives on science and the unknown. In the realm of science, the concept of parallel universes has spurred significant interest and debate, pushing researchers to explore new models of reality that challenge classical understandings of space, time, and matter. The many-worlds interpretation of quantum mechanics, for example, arose as a response to the measurement problem and the apparent randomness of quantum events. by proposing that every possible outcome of a quantum measurement actually occurs in some branch of a vast multiverse. This idea expanded the scope of theoretical physics and encouraged scientists to reconsider the nature of probability and determinism. The exploration of parallel universes also intersects with cosmological theories, such as the inflationary multiverse, which suggests that our observable universe is just one bubble in an immense cosmic foam of universes with varying physical constants. These frameworks invite physicists to investigate phenomena beyond traditional boundaries, employing mathematical rigor and innovative experiments to test the predictions these theories make. This scientific engagement with parallel universe concepts has had the effect of pushing the boundaries of what is considered scientifically plausible. While empirical verification remains elusive, the dialogue generated by these ideas encourages scientists to develop novel tools, refine theoretical frameworks, and engage in interdisciplinary collaboration. Fields such as quantum computing, particle physics, and cosmology benefit from this intellectual cross-pollination, with advances in one area potentially illuminating aspects of another. For instance, the pursuit of understanding entanglement and superposition in quantum systems directly relates to interpretations involving multiple realities, driving technological innovation and deepening comprehension of the quantum world. Beyond academia, the hypothesis of parallel universes has significantly contributed to the popularization of science. Media, literature, film, and other forms of popular culture have embraced these ideas, translating complex scientific notions into accessible and often thrilling narratives. This widespread representation serves multiple functions. It educates the public about cutting-edge scientific theories, stimulates curiosity and wonder, and provides a shared language for discussing profound questions about existence. Television series, blockbuster movies, and best-selling novels featuring parallel worlds have reached vast audiences, embedding scientific concepts into everyday conversations and making science more approachable. This popularization often sparks interest among young people, inspiring new generations to pursue careers in science, technology, engineering, and mathematics. The cultural penetration of parallel universe ideas also influences societal worldviews and philosophical perspectives. Concepts of multiple realities challenge traditional monolithic understandings of existence and encourage a more pluralistic outlook. They raise questions about identity, fate, and free will, inviting reflection on how different versions of ourselves might exist under varying circumstances. This pluralism resonates with contemporary discussions in philosophy and spirituality about the nature of consciousness, reality, and the self. The notion that there may be countless versions of reality existing simultaneously encourages a shift away from deterministic or singular narratives toward more fluid, open-ended models of human experience. Moreover, the engagement with parallel universes invites reconsideration of humanity's place in the cosmos. It expands the scale of reality from a single, finite universe to a vast multiverse teeming with possibilities, fostering a sense of humility and wonder. This cosmic perspective can influence ethical considerations, motivating stewardship of our own universe and promoting curiosity about the unknown. It also encourages interdisciplinary dialogue, linking physics with metaphysics, theology, and even the arts, enriching cultural discourse and broadening intellectual horizons. In the arts and cultural trends, the impact of parallel universe concepts is vividly apparent. Writers, filmmakers, visual artists, and game designers frequently draw upon these ideas to explore themes of alternate realities, identity crises, and the consequences of choices made in divergent timelines. Such works often use the framework of parallel universes to probe complex psychological and social issues, making abstract scientific ideas tangible and emotionally resonant. The aesthetic and narrative possibilities afforded by the multiverse concept have expanded creative horizons, resulting in innovative storytelling techniques and genre-blending narratives that captivate audiences and provoke thought. Socially, the fascination with parallel universes has fostered communities and subcultures centered around speculative science and metaphysics. Online forums, conventions, and discussion groups provide spaces for enthusiasts to exchange ideas, share experiences, and debate interpretations. This communal engagement promotes science literacy and critical thinking, while also sometimes blurring lines between scientific discourse and speculative or fringe beliefs. The challenge lies in maintaining a balance between open-minded exploration and rigorous skepticism, ensuring that enthusiasm for extraordinary ideas does not lead to misinformation or pseudoscience. The influence of parallel universe hypotheses also extends to education, where they are increasingly incorporated into curricula and public science communication. By presenting students with questions that touch on the limits of current knowledge, educators stimulate critical inquiry and creativity. These topics encourage learners to grapple with uncertainty, appreciate the provisional nature of scientific theories, and understand the iterative process of discovery. The integration of such cutting-edge concepts into education helps prepare students for a world where science continually evolves and where interdisciplinary thinking becomes ever more vital. On a societal level, the widespread interest in parallel universes reflects and contributes to a broader cultural trend toward exploring alternative realities, whether through virtual environments, immersive technologies, or philosophical inquiry. As technology advances, the boundary between imagined and experienced realities becomes increasingly porous, and concepts once confined to theoretical physics resonate with lived experiences in digital and social spheres. This interplay enriches cultural life and prompts ongoing questions about authenticity, perception, and the nature of existence. However, the impact of these ideas is not without complexity. The popular appeal of parallel universe theories can sometimes lead to the oversimplification or misrepresentation of scientific principles. Sensationalist media coverage or speculative fiction may conflate fiction with fact, creating misconceptions that challenge effective science communication. Furthermore, the allure of multiverse ideas may encourage some to prioritize speculative scenarios over pressing empirical research, potentially diverting attention from more immediate scientific challenges. Despite these challenges, the hypothesis of parallel universes remains a powerful catalyst for expanding human knowledge and imagination. It serves as a bridge between the known and the unknown, inviting inquiry into some of the deepest questions about reality. Its impact on science fosters innovation and interdisciplinary collaboration, while its cultural resonance encourages reflection on identity, choice, and existence. As society continues to grapple with rapid technological and intellectual change, the ideas inspired by parallel universes will likely remain a vital part of the conversation, shaping how we understand ourselves and the cosmos. In conclusion, the hypothesis of parallel universes has left an indelible mark on science and society by broadening scientific horizons, popularizing complex ideas, influencing worldviews, and inspiring cultural expression. It challenges traditional conceptions of reality and encourages a spirit of exploration and wonder that resonates across disciplines and communities. While much about parallel universes remains speculative and awaits empirical confirmation, their conceptual power continues to stimulate curiosity, creativity, and critical thinking, reflecting humanity's enduring quest to comprehend the vast and mysterious nature of existence. The prospects for research and technology development related to the understanding of the multiverse and the potential for travel between parallel universes are both exciting and challenging. Although the concept of parallel universes remains largely theoretical, ongoing advances in physics, cosmology, quantum mechanics, and related technologies may gradually bring us closer to exploring these ideas in more concrete and practical ways. The intersection of fundamental science and cutting-edge technology creates a fertile ground for progress, where new experimental methods, theoretical breakthroughs, and technological innovations could collectively open pathways toward deeper insights into the multiverse, and perhaps one day, the possibility of crossing between worlds. At the forefront of these prospects are developments in high-energy physics and particle accelerators. Large-scale experiments, such as those conducted at the Large Hadron Collider, LHC, and planned future colliders, aim to probe conditions that existed just after the Big Bang. By recreating these extreme energy levels, scientists hope to uncover new particles and interactions that could provide clues about the fundamental structure of reality. Discoveries related to extra dimensions, dark matter, or exotic particles might support theories predicting the existence of multiple universes or hidden realms beyond our observable cosmos. Such empirical data would be crucial for validating or refining multiverse hypotheses, providing a stronger scientific basis for further research. Quantum computing represents another promising technological frontier with significant implications for understanding parallel universes. Quantum computers operate by exploiting principles such as superposition and entanglement, which are closely linked to many worlds' interpretations of quantum mechanics. As quantum computing technology matures, it enables simulations of increasingly complex quantum systems that were previously impossible to model. These simulations could help physicists test and visualize how quantum states evolve, potentially shedding light on the nature of quantum branching and the structure of multiple realities. While quantum computers do not directly provide a means of interuniversal travel, their development enhances our grasp of the quantum world, which underpins many theories of parallel universes. Advances in cosmological observation techniques also hold great promise. Instruments like the James Webb Space Telescope, ground-based observatories, and future space missions are expanding our ability to observe the universe with unprecedented precision. By studying cosmic microwave background radiation, gravitational waves, and the large-scale structure of the cosmos, scientists may detect subtle anomalies or patterns that suggest the influence or existence of other universes. For instance, collisions between our universe and others during the inflationary period could leave detectable imprints. Continued improvements in observational technology, combined with sophisticated data analysis powered by artificial intelligence, could enable the identification of such faint signals, moving the multiverse hypothesis closer to empirical testing. Theoretical research is equally vital to advancing our understanding. Ongoing work in string theory, M-theory, and quantum gravity seeks to unify the fundamental forces of nature and explain the architecture of reality at its deepest level. These theories often predict the existence of higher dimensions and multiple universes as natural outcomes. As mathematicians and physicists develop more refined models and explore their implications, they identify new testable predictions and propose novel experiments. Cross-disciplinary collaborations between mathematicians, physicists, and computer scientists accelerate this progress by leveraging diverse expertise to tackle complex problems that lie at the intersection of geometry, quantum physics, and cosmology. On the technological front, the hypothetical concept of creating or harnessing wormholes or other energy portals as gateways between universes remains a distant goal, but inspires innovative thinking about energy manipulation and space-time engineering. Although current technology is far from achieving such feats, research into quantum field theory, exotic matter, and negative energy density is advancing our theoretical understanding of these phenomena. Future breakthroughs in controlling energy at quantum and cosmological scales could eventually enable experiments aimed at stabilizing wormholes or constructing artificial conduits through space-time. Such developments would revolutionize not only physics, but also propulsion technology, communications, and our broader relationship with the cosmos. The development of sophisticated quantum sensors and detectors offers another practical pathway toward investigating multiverse theories. These devices, capable of measuring quantum fluctuations and subtle gravitational effects, can probe phenomena that might indicate interactions with other universes or the presence of hidden dimensions. As these sensors become more sensitive and versatile, they could be deployed in space missions or ground-based experiments designed to search for anomalous signals. Enhanced precision in detecting quantum entanglement over large distances might also contribute to understanding the connectivity between different branches of reality, if such connections exist. Artificial intelligence and machine learning technologies increasingly play a crucial role in managing and interpreting the vast amounts of data generated by experimental and observational efforts. The complexity of multiverse-related phenomena requires sophisticated algorithms capable of identifying subtle patterns, correlations, or anomalies that human analysis might overlook. AI-driven modeling and simulation tools help researchers explore theoretical landscapes, optimize experimental design, and predict outcomes under various scenarios. This integration of computational power with fundamental physics accelerates discovery and facilitates the exploration of ideas that were previously inaccessible. While much of this research remains foundational, the gradual accumulation of knowledge and technological capability lays the groundwork for future practical applications. Should interuniversal travel become physically possible, it will likely require harnessing extreme energy sources, advanced materials, and precise control over space-time geometry. The challenges are immense. Energy requirements might surpass anything currently achievable. Stability of transitional pathways must be ensured, and safety protocols for navigating unknown realities would need to be developed. However, history shows that what once seemed impossible can become reality through incremental progress, interdisciplinary collaboration, and visionary innovation. In the nearer term, the exploration of multiverse theories contributes indirectly to technological and scientific advances with broad applicability. Research into quantum mechanics and cosmology drives progress in computing, materials science, energy technology, and space exploration. Even if direct contact with parallel universes remains elusive, the quest to understand these concepts enriches our technological toolbox and expands the frontiers of human knowledge. This ripple effect underscores the intrinsic value of fundamental research, even when its immediate practical benefits are not apparent. Ethical and philosophical considerations will also influence the trajectory of research and technology development related to the multiverse. The potential discovery of other universes or intelligent entities beyond our own raises profound questions about responsibility, exploration, and the impact of human activity on previously unknown realms. These considerations highlight the importance of integrating ethical reflection into scientific advancement, fostering a culture of responsible innovation that respects the broader implications of discovery. In conclusion, the prospects for research and technology development connected to parallel universes and multiverse theories are expansive and multifaceted. Advances in high-energy physics, quantum computing, cosmological observation, theoretical modeling, and emerging technologies collectively contribute to a gradual unveiling of the deeper structure of reality. Although the possibility of traveling between parallel universes remains speculative and faces formidable obstacles, the ongoing pursuit of knowledge in this area drives scientific innovation, enriches our understanding of the cosmos, and inspires imaginative visions of the future. As humanity continues to push the boundaries of what is known and what is possible, the exploration of parallel universes will remain a compelling frontier at the intersection of science, technology, and philosophy. The question of whether traveling to a parallel universe is possible and whether travelers from such universes might already be among us, is one that sits at the intersection of cutting-edge scientific theory, philosophical inquiry, and cultural imagination. Throughout the exploration of this topic, we have seen that while the notion of parallel universes is supported by several influential theoretical frameworks in physics, such as the many-worlds interpretation of quantum mechanics, string theory's multiverse concepts, and cosmological inflation models, the actual possibility of traveling between these universes remains a profound challenge fraught with unresolved questions and practical obstacles. From a scientific standpoint, the existence of parallel universes is not outright disproven. Indeed, some models suggest their very real presence. The many-worlds interpretation posits a constantly branching reality, where every quantum event spawns alternate outcomes, effectively creating countless parallel worlds. Similarly, string theory's brane cosmology and inflationary cosmology introduce frameworks in which multiple universes coexist, perhaps layered across additional dimensions or isolated in a vast cosmic landscape. However, these theories largely remain speculative, with empirical evidence currently limited or indirect. The fundamental physical mechanisms that might enable crossing from one universe to another, such as stable wormholes, quantum tunneling, or exotic energy portals, are theoretical constructs without practical demonstration. The enormous energy requirements, the instability of potential gateways, and the extreme conditions needed to create or access such pathways present formidable barriers far beyond current technological capabilities. On the experimental front, scientific efforts to detect signs of parallel universes through anomalies in cosmic background radiation, quantum system behaviors, or high-energy particle collisions have not yielded definitive proof. These investigations continue to push the boundaries of measurement precision and theoretical prediction, but remain inconclusive. As such, from a strictly empirical perspective, the hypothesis of parallel universe travel and the presence of travelers from other universes among us is not currently supported by reliable data. The absence of observable, verifiable phenomena attributable to such travelers suggests either that these transitions do not occur, that they are extraordinarily rare, or that our detection methods are insufficient. Philosophically and ethically, the idea of interuniversal travel raises deep questions about identity, causality, and responsibility. If alternate versions of ourselves exist, what does it mean for personal identity when confronted with these versions? What actions in one universe impact another, and what ethical obligations might arise from such interference? These questions remain largely theoretical, but are essential for framing any future attempts to explore or interact with parallel realities responsibly. Culturally, the hypothesis has permeated human imagination, influencing literature, film, and folklore. Stories of travelers crossing dimensions or encountering non-human entities from other realities abound in myth and popular culture, reflecting a persistent fascination with the unknown and the boundaries of existence. However, these narratives, while enriching, are often symbolic or allegorical rather than empirical evidence. The suggestion that travelers from parallel universes are already among us often arises in discussions involving anomalous phenomena, mysterious disappearances, and encounters with inexplicable entities. While intriguing, these reports lack the rigorous verification needed to constitute scientific proof. Many such phenomena have alternative explanations rooted in psychology, misinterpretation, or natural events. Scientific skepticism rightly emphasizes the importance of methodological rigor, reproducibility, and empirical evidence, cautioning against accepting extraordinary claims without extraordinary proof. Despite these challenges, the pursuit of understanding parallel universes and the potential for travel between them continues to inspire scientific innovation and philosophical exploration. The development of new technologies, ranging from quantum computing to advanced cosmological observatories, and theoretical advances in physics may one day shed clearer light on these questions. The refinement of experimental techniques might reveal subtle effects or anomalies pointing toward the multiverse's reality or even the existence of pathways connecting different universes. In considering the likelihood that travelers from parallel universes are already among us, the balance of evidence and reason suggests it is currently very low. The absence of verified interaction, the lack of credible empirical data, and the immense technical difficulties involved all point toward this scenario being highly improbable with our present understanding. Nonetheless, the possibility cannot be entirely ruled out, especially given the limits of our current knowledge and technology. As science advances, what is deemed impossible or unlikely today may become plausible or even realizable in the future. In conclusion, traveling to a parallel universe remains a fascinating theoretical concept supported by certain interpretations of modern physics, but remains beyond practical reach at this time. The hypothesis that travelers from other universes already walk among us, while captivating, lacks credible scientific support. These topics underscore the profound mysteries at the heart of our understanding of reality and encourage ongoing inquiry. Future research must continue to refine theoretical models, improve experimental methods, and address the philosophical and ethical implications of such discoveries. The questions surrounding parallel universes are among the most profound in science and philosophy, inviting humanity to explore not only the cosmos, but also the very nature of existence itself.